systems, changes in industry, because if you have um, mountains and rivers and things, you have hydro energy, etc. So whether there's been an impact on energy systems and food security, all the way down to whether there's been impacts on human health, human migration, culture, and tourism, right? So essentially things that you care about. Now, climate change is doing many things to temperatures and humidities and rainfalls. But finally, what you really care about is what it's doing to you economically, socially, culturally, and physically in terms of your health, right? So if you're able to attribute those working up the chain to what we did in terms of emissions of greenhouse gases and aerosols, then this is what is called an end-to-end attribution, right? So what they've done is they've based it on literature and, just doing a meta analysis of published literature and do. But this is something that is actually ripe for AI/ML, because each of these individual steps should be possible to do, because you're now dealing with different kinds of data with their own features and characteristics. Some of it is social data, some of it is ecology and other things. So how we are able to attribute from one step to the other is something that I think is a problem that we really need to tackle. A second example of this is when we look at extreme events, weather and climate events. And what we mean by extreme weather and climate events is, just your typical heat wave or a heavy downpour, maybe a tropical cyclone. So these are all extreme events. And if you look at this distribution in the world that preceded human activity going berserk and literally, emitting all kinds of things. A distribution of a particular climate variable would have. Is there something wrong on one side and not the other? Okay, I'm going to continue since it's on. The distribution looks different than in the world where we have changed everything, right? This is the actual world where we have the red curve. And so you can see if we have some sort of a threshold for when something becomes dangerous, your probability of the event occurring has changed. You now have a new probability P1, which is higher than what it used to be, which is this P0. And this fractional attribution ratio is something that tells us how much climate change has actually contributed to the fractional attributional risk, rather, how much it has contributed to our risk. So this is done fairly routinely these days. In fact, the group I mentioned, World Weather Attribution, that I volunteer for every once in a while. What we do is when there is an actual extreme event unfolding in real time, we try and figure out if there's a difference between P1 and P0. Okay? So essentially what it involves is we have to define what the event that is happening is, which part of the world is either experiencing extreme heat or extreme rainfall, and kind of come to and then figure out if the observed magnitude is so much more than what is within the realm of um, distributions that occur without human-induced climate change, and whether it's more probable in the world where we have. So this is all done through models, climate models, etc. And you can also do it using observations. If you have long enough observations, dating back to when you think there was really not much human influence. For example, if you have temperatures going back into the 1800s, then you know that the human influence on those temperatures and rainfall was not that much. So, so you can use that as your counterfactual period. So this is something that is routinely done. So this is what we call probability-based technique. Then there's something called a storyline approach, where you essentially say that these are the features of this kind of an event. It has these dynamically consistent look and feel to it. I'm going to isolate all of those in the real world that we have and in the counterfactual world. So again, using a lot of model simulations. So these model simulations, of course, are climate models fully coupled and have multiple kinds of forcings so that you can isolate what is factual, what is counterfactual, etc. So it's cumbersome, and so clearly somebody decided we already have all these models. We're going to, and this is paper from last year, so we're going to train, CNN to have this entire set of models that it looks at and is able to quickly tell us whether a particular event, first of all, has an intensity that rises as the global mean temperature rises, or can tell us if the frequency of such an event can increase, right? So you can have an extreme event that changes in these two kinds of ways. And a third also, but mainly it's suddenly your heat wave is stronger, more intense, or your heat waves come more frequently. And if you use it as a measure, perhaps as something that has a larger aerial extent. So you can use multiple criteria like that. So their CNN essentially is able to do this for multiple kinds of events. And what they looked at is the heat wave that occurred in North India in 2022. And so this is, for people who may have forgotten, we started getting warm in February. Early to mid-February, it started getting warm. By March and April, it was really hot, and it just stayed hot for multiple months, much too early. And this had a huge impact. So anyway, they've run through some standard analyses. We had done a classical probability approach attribution for this event, and so they've kind of got reasonably similar results, just to demonstrate that this is a cheaper, once you've done the training of the model, it's a cheaper to use on the fly model, right? So to us, though, the story of this heat wave, yes, it was meteorologically and physically, it was all very interesting. But the real story actually is captured in this figure, where we're looking This is from our paper where we attributed this event. So it's looking at the impact pathways for a heat wave and what it does to different parts of our economy and society, right? So agriculture was one huge thing. There was actual 10 to 20% estimated drop in the wheat yield. There were impacts on the environment. There were health impacts that occurred at the same time. And the economy took a hit, we think, because nobody in India has quantified any of these things, right? So we know that there were changes to what the railways did, et cetera, et cetera. So there's been all of these impacts on various parts of our our nation's being, that we think that unless we get a handle on being able to predict what is happening to us as a consequence of the increased greenhouse gases, et cetera, we really don't have a full appreciation of the costs to us, and therefore, whether we should do something more urgently or we can just kick back and say, we'll bear the costs and we'll move on because it's not such a big deal. Yeah. Yeah. Well, the point is we don't have any data, or we didn't go into that part of it, because each of these is in itself a big beast that is possible to do. We just didn't have the knowledge or the bandwidth to go into that. So my exhortation in this talk is that this is something that needs to happen. Somebody needs to do this. Somebody needs to look at the climate and the weather that is unfolding and be able to connect it to other things that are happening. Another example, last year's floods or landslides in Wayanad. Okay, so again, we went in as part of world weather attribution. We were able to say that the rainfall was heavier and it was 10% heavier because of human-induced climate change. But then, was the landslide because of that? We don't know. We can't say that yet. We can say that there was land use change in that region. There was a little more construction going on, little more deforestation had happened. So it made this area more susceptible to a landslide. So part of this work is based on my colleague Manabendra Saharia, who used, so for many years now, the GSI, Geological Survey of India, has had landslide maps, right? But those were completely based on geotechnical considerations. Now he has developed, using AI/ML, his new landslide susceptibility map, which takes into account all of the physical, geotechnical factors as well as the meteorological factors. So this is the whole set of things, and also whether there's proximity to roads, which is an indicator of how much that land or that piece of mountain is likely to have been. So when you look at, for example, what's happening this monsoon in the Himalayas as more and more construction of these massive highways, etc., is going on, is you can see this play out in terms of where some of these factors might be. So you see here that precipitation is somewhere in the middle of this feature importance score. There are other features that are much more important, and you can, so to be able to attribute a landslide to a particular rainfall event, therefore, is fraught with many things. There are many things that are probably happening because of how we have done things through construction and through faulty practices, etc., etc. And those also need to be factored in and be able to be modeled. So my final slide here. So why does all this matter? So I'm trying to put, yeah. Yeah. Yeah, so there's been attempts at this. So it so happens that the impact that you're talking about is not something that we've mapped out. It's only in the last few years that we even have a flood map of India, because we have not tracked, we don't measure all the rivers in all the places, their stream flow or the heights and all of those is not in any database. So people are trying to actively reconstruct all of the floods that might have happened. But then again, in India, even with floods, the biggest problem is that you don't have information about all of the human interventions of check dams and culverts and this and that, canals that have been put in. So none of the hydrologists can really fully get a handle on how is this river flowing, and is it natural, is it human interfered, etc. So there's many problems with even getting a handle on what has happened. So I think there needs to be some thinking. This actually needs. There are some obvious ones. If I'm a hydrologist, I'm looking at landslide. I was a civil engineer looking at this geotechnical stuff and flooding and these kinds of things. So it's obvious there are medical people looking at health effects, but there's nearly not enough economists looking at anything in terms of quantifying the rupees and dollars of everything. And so I think just to have a mental map of what are the impacts that we need to be looking at, and how do we uh, have a systematic data collection, and an architecture to look at using that data is something that I think is an important thing to be done. And that's one of, so absolutely. Oh yeah, the thing is that, if you just look around at the kinds of papers people are writing, it rankles you that, my goodness, I don't even have flooding data for Yamuna. We just don't, you know. And so you're here in Delhi and you're left wondering in what way you can, remedy the situation. But I think, all said and done, I think if enough people are mobilized to make this a priority, uh, there are many pockets of data that exist. There's probably a large effort of going through personal archives or lab archives and, kind of curating all of that data. But these are things that people spend whole careers on. And so it's in many ways very unsexy work, and low returns if you want to be writing papers every day. But it has to happen. So because we need to get an estimate of what climate change is responsible for and also not responsible for, because it becomes the easiest thing whenever something happened in Uttarakhand, uh, and then, somebody quickly comes and says this is climate change. I mean, we have not, we don't have the data there to be able to say that with confidence. We don't. So we should have the data. We should have the tools to do that. But till, so this is again something that we, and there's a legal liability question here, right? So, and this is not just playing at local players. This is now part of many global lawsuits that are going. Just 2 days ago, there was a paper listing out all the um, heat waves that have occurred in the last 20 plus years and affixing the role of each of the major oil companies in those heat waves. Okay? So this is, people have quantified this. They have said these companies are responsible. So one of these days it's going to show up in the court of law where attribution science is going to be called upon to testify that this is what happened and this is how we arrived at that. So again, data here. Data becomes important and to follow through on. And there's also something called loss and damage, and this is something that's part of the United Nations Framework Convention on Climate Change, the Conference of Parties. So this is a concept where there's a fund, and if you have suffered some loss, then damages will be paid by, quote unquote, the responsible party. So high emission countries whose emissions are responsible for these will compensate the people who have suffered the losses. So there are damages to be paid. So of course, this is still under negotiation, but attribution, and again, not just being able to say rainfall changed or temperature changed, but that particular loss, that this island country that I lived in is no longer there because of what you've done to the sea level, is the kind of thing where the attribution then leads to a finding of a loss and awarding of damages. So I'll stop here and happy to take any further questions you may have. Yeah.
Coming to and we are trying to quantify that, because that would make it again higher orders more.
So if I understand your question correctly, you're saying some company did what to the CO2?
Like you can get direct attributions, like the company X did something which, let's just say, offset the carbon footprint or something like that, and we will be putting that out. Let's just say that it's creating heat waves and things like that. But it can be that the attribution over here is second hand or third hand. Like they did something which had a consequence, which had a consequence.
Correct.
So now these would be long-lasting effects. Like it would not be like something happened today and it would be affecting it tomorrow. It might happen in the next 50 years.
Correct.
So like industrial revolution happened like hundreds of years ago.
Yeah. Yeah.
And we are suffering the consequences now.
Yeah.
So those type of attributions, I mean, we might not even have the data, but then these types of things.
So yeah. So I get your point. So what people do in terms of affixing the responsibility currently is that there is a notion of how much a country or a company has emitted. Okay, so if let's say you're the United States, then historically what your emission is something that's fairly well known. Similarly with all of the oil companies, etc., right? The cement companies. So because all of their productions and everything is in balance sheets, and so it's their own data. So people are using that to sort of know how much they have emitted. Now, at some point, they didn't know what they were doing would have this detrimental effect, right? So in that sense, you can't be held responsible for something that was unknown at that point. But it's been well established since the mid-90s that there is this causal chain. So the moment you know that, and you see board meetings in the Exxon Mobils and other big oil companies claiming that none of this is a result of our business, while their own internal scientists had written papers and memos pointing out that this is a big liability. So they've been caught trying to be, playing two sides. So a lot of the lawsuits are kind of based on that. It's that you knew this, not that you did something unwittingly, but that you knew this and still did it. So there's a difference, because how many ever levels of attribution, the fact that even the step one has happened and your scientists have told you it will have an effect, it's cause enough to be careful. Yeah.
This is about how we generate the counterfactuals using models for attribution.
Yeah.
So for India especially, I feel like in a lot of these flood events or extreme rainfall events, sometimes they tend to be very local, right? Very intense rainfall over a couple of days on a very small area. And then you have the climate models which are on a coarser scale, right? So how far down the road, like how far along are we sort of getting these kind of events?
Yeah, good question. This is about whether something that happens in a small area is captured in climate models, which are typically very coarse, of the order of hundreds of kilometers, grid size. So this is a problem. And this is certainly a problem with a quantity like rainfall, where the scales are much smaller, right? And so when you look at attribution studies, there's a clear difference in the sheer number of studies that have attributed temperature-based things, because temperature behaves much better and you have both the factual and the counterfactual being simulated better in the models. Whereas something like a cloudburst or even a tropical cyclone is much harder to attribute precisely because of that problem. And this is where I think potentially AIML could be a way of, but it still doesn't solve the problem of having to have these high resolution simulations somewhere. Okay, I think we Thank you.